synthesis of alpha terpineol. Actually, here two syntheses were introduced. First was only by the one scientist, Perkin Jr. Perkin reaction. That Perkin reaction is given by the senior junior Perkin. Then there was a new another Perkin, who was known as Perkin Jr. So now Perkin Jr. in 1904, he proposed a synthesis. In 1904, then again 1908, there was another company, his research fellows, Perkin et al. Perkin Jr. along with two more scientists, Meldrum and Fisher. Meldrum and Fisher. These are the two more companions. They proposed another synthesis. Now we are doing that synthesis which is given by the Perkin Jr. plus Meldrum and Fisher, which was proposed in 1908. There is a more easy one, that is in which the Diels-Alder reaction is used. We will do that one. But now here we are doing this synthesis which is proposed by that was given by it was a company of three scientists, Perkin Jr., Meldrum and Fisher. In this case, the starting material is this one. Now 1, 2, 3, 4. Or say ortho, meta, para. So we can say it is 4-methyl benzene, 1-carboxylic acid, or methyl carboxylic, methyl benzene is a toluene, so it is toluic acid. Again, which toluic acid? 4-toluic acid or para-toluic acid. Because the fourth position is para position, it is para-toluic acid. So the reaction was started with the para-toluic acid, and there was, you see, one of the reaction is known as what is the name? I exactly don't remember. Koch reaction, in which the hydroxylation is carried out. In that reaction, actually it is the benzene ring. Any compound, aromatic compound, is treated with the sulfuric acid. Then sulfonation takes place. Sulfonic acid group is introduced into the ring. Then it is treated with the, say, potassium hydroxide base. So the sulfonic acid is converted into its salt, potassium salt. And then it is Kolbe reaction. Oh yes, it was Kolbe reaction. Then it is treated with the hydrolysis, acidic hydrolysis. So in this case, what is happening? Hydroxylation takes place. Now again you see carboxylic acid is here. Why is now here you see carboxylic acid is this. जी.
सर खाली पर्किन जूनियर आ रहा है या ये देखो पर्किन बेन सा गद दिनो वो है
बेन सा गद वारो ही जो अलग विधि बुधाऊं ताकि जो 1908 में आयो ना वो भी है ये टे रिएक्शन है तीन में को फिर है सफा सिंपल वो बता आखिर वो अगली लाइन जो है
सर टोटल टे निकड़ो पर्कन सीनियर दिनो वो पर्कन जूनियर आयो पोरी पर्कन जूनियर जी दिनो
ना हिकिड़ो सिर्फ पर्किन जूनियर ॾिनो पर्किन सीनियर जो है पर्किन रिएक्शन है वो रिएक्शन में छा थींदो है कार्बोक्सिलिक एसिड उन जो एनहाइड्राइड प्लस उन जो साल्ट इहो यूज थींदो उन में अल्फा बीटा अनसैचुरेटेड द कंपाउंड इज फॉर्म्ड इफ यू वांट टू प्रिपेयर सिनेमिक एसिड then cinnamic acid we can prepare by the Perkin reaction. That Perkin is senior. Here Perkin junior. Only one method was given by the single person, Perkin Jr. in 1904. Then second method was given with the Perkin along Perkin Jr. plus its company, the Meldrum and Fisher. Perkin Senior reaction कौन ॾिनो? Perkin जो reaction जेके वो ॿिया reaction. उनजी त मिसाल तौर हिकिड़ो formation of alpha, beta, unsaturated carboxylic acid. For example, cinnamic acid. Cinnamic acid we can prepare by using the Perkin reaction. That Perkin was the senior Perkin. So it is the Perkin Junior. First method was proposed by the Perkin Junior alone in 1904. Second method was proposed, which was in 1909, along with Meldrum and Fisher. So now we are doing this reaction, which is given the method which was given by the company. That is Perkin Junior plus Meldrum plus Fisher in 1908. In Kolbe reaction, if you study the Kolbe reaction actually this reaction is used to introduce the hydroxy group into the aromatic ring. So now here, if you use sulfuric acid, sulfuration will take place. Again, sulfonic acid is the acid. Any acid, when it is treated with the potassium hydroxide, potassium salt is formed. When potassium salt is again hydrolyzed, then what happens? The hydroxy group will replace the sulfuric acid. This is the mechanism given in the Kolbe reaction. And BS values, look here how the Kolbe reaction is taking place. It is very simple. So now I'm not doing that reaction. I'm just telling you how the hydroxy group is introduced into the aromatic ring. So now here actually hydroxylation is carried out. So hydroxy group is introduced into the aromatic ring. At which position hydroxy group will be introduced? Here you see one methyl group, another carboxylic acid. Carboxylic acid group is ये बाबा कुछ हो जा कुछ
बिना सर 8 को पोजीशन में बताओ
सर कोल्बे इलेक्ट्रोलिसिस और रिएक्शन ही है ना ये
रिएक्शन है कोल्बे है ना कोल्बे
सर कोल्बे इलेक्ट्रोलिसिस
देखो कोल्बे ये भी रिएक्शन मुझे एग्जैक्ट ना लगो reaction actually the reaction is used to hydroxylate the aromatic compound to introduce the hydroxy group into the aromatic ring. ये BS बैल मिर्जा preparation of phenols जो chapter phenols phenol chapter होता उनमें reactions होता preparation होता तो उनमें कोई reaction उनमें सब preparation of phenols में देखो reaction होता जैसे how to introduce the hydroxy group into the aromatic ring. Detail is not about study how to introduce the hydroxy group into the phenol. That is how we can prepare the phenol. So just look into the chapter phenol. In the preparation of phenol, that will be this reaction was given. There are two reactions, most common reactions, in which we can introduce the hydroxy group into the aromatic ring. So here, in the aromatic ring, hydroxy group is introduced. Before hydroxy group is a nucleophile. And the aromatic, they are not easily undergoing the nucleophilic reactions. Their common reactions are, characteristic reactions are electrophilic substitution. So first we introduce the sulfonic acid, which is electrophile, then change into salt, then followed by the hydrolysis, that will be replaced by the OH group. Otherwise, simply directly we cannot introduce the OH group. That only can happen when the ring contains the all electron attracting group. Here methyl group is electron donating group. Ring activating group. Here ortho para directing group. The carboxylic group is electron attracting group. Ring deactivating group. Meta directing group. So now when the hydroxy group is introduced, first it is sulfonated, then its salt is prepared, and then followed by the hydrolysis. So now next problem is at which position the hydroxy group will be introduced. You see, the methyl group is ortho para directing group. This is carboxylic group is meta directing group. And whenever the two groups are aligned, if both are ortho para directing group, then we'll meta directing. Again, with respect to this, these are the meta positions. This will, in the presence of this ortho position, will not be affected. So normally the OH will be introduced either on this side or this side. Same compound is produced. Now let me write here. The hydroxy group is introduced at the ortho position. So either you write on this side or this side. That will be both are ortho. Same compound will be produced. Now we can call meta-hydroxytolic acid. With respect to this, 1, 2, 3, 4 are here ortho, meta, para. So it is meta-hydroxytolic acid. How it is produced? Whenever the para-tolic acid is treated with the sulfuric acid, followed by potassium hydroxide, and then hydrolysis with the acidic hydrolysis. And when this compound meta-hydroxytolic acid was treated with the sodium and ethanol,
सर
If you remember the reaction in the जी
सर ये जो तव्हां ॿुधायो न हींअर त कार्बोक्सिलिक ग्रुप जेको इलेक्ट्रॉन विड्रॉइंग ग्रुप ऐं इन मिथाइल जेको इलेक्ट्रॉन डोनेटिंग ग्रुप आहे ठीकु आहे त उन जे हिसाब सां उन जो इफेक्ट बि चेंज थींदो हाइड्रोक्सी हिते लॻो इहो वरी कीअं
सही
रिपीट कजो हाइड्रोक्सी हिते कीअं लॻो
यार हेतिरो मथो कुॾियो चवां थो कोल इहो रिएक्शन ॾिसो त कीअं हाइड्रोक्सिलेशन कीअं फिनोल जी तव्हां प्रोपेशन ॾिसो त ख़बर पए न तव्हांखे
जी सर
फिनोल कीअं ईंदो इंट्रोड्यूस फिनोल कीअं था कनि इहो पाण करे तव्हां कयो कोन्हे इलेक्ट्रोफिलिक सब्स्टिट्यूशन एरोमेटिक सिस्टम ॿ रिएक्शन आहिनि ॿुधायां थो ॿिन्ही में इंट्रोड्यूस थींदो हाइड्रोक्सी ग्रुप हाउ टू इंट्रोड्यूस द हाइड्रोक्सी ग्रुप इनटू द एरोमेटिक रिंग अॼु सेंसिस करे वठो जेकॾहिं सुभाणे तक नथो अचे त इहो रिएक्शन कराईंदुसि ये बेसिकली पाण थर्ड ईयर में सेकेंड में करे आयो हाउ टू प्रिपेयर द फिनोल्स फिनोल कीअं प्रिपेयर कबा ऐं नालो ई कोन वठां कोलबे जो नालो वठंदो न कोलबे छॾे ॾियो तव्हां ईअं सम्झो था हाउ टू प्रिपेयर द फिनोल दैट इज हाउ टू इंट्रोड्यूस द हाइड्रोक्सी ग्रुप इनटू द एरोमेटिक रिंग दिस इज द रिएक्शन hydroxy group can introduce directly hydro groups cannot be introduced because the hydroxy group is a nucleophile and the most common reactions of the aromatic compound they are electrophilic substitution hydroxy group is nucleophile so nucleophile only can be introduced whenever like pyridine now I was saying that just to study yourself you have done it. No need to do the reaction that how to hydroxylate the aromatic ring. I told you the one of the name of this, that there are more than one reactions in which we can introduce just hydroxy group. Look into the chapter phenols. Phenol chapter and its preparation. In preparation the reactions are given. How we can introduce the hydroxy group into the aromatic ring. Just to study that reaction, you will know that how we can introduce this, how the sulfonation take place, how then converted into acid, the salt, then how that salt will be converted into hydroxy group. In detail, just you see into the chapter phenol, preparation of phenol. Now you are in final year. At least you must know how we can introduce the phenol hydroxy group into the aromatic ring. How to prepare the phenols. So don't be confused with the Kolbe. मुझे Kolbe वठी नाल वठी जॾियो त Kolbe इलेक्ट्रोलिसिस त ॾिसो थी आहे छा उहो हिकु दफ़ो ॾिसो त पाण ख़बर समझ में अचे न समझ में अचे त तव्हां सम्झाईंदो पर तव्हां पाण मूंखे यकीन तव्हां ॾिसो तव्हां समझ में अची वेंदो ॾुखियो रिएक्शन आहे ई कोन दैट इज रिएक्शन इज formation or preparation of phenols. So now and the next problem is that at which position it will be introduced. Directly nucleophile cannot be introduced into the aromatic ring. If nucleophile will be introduced, again it will not follow this electron donating group. Always it will follow the electron attracting group. But now first, that is why we are first introducing the electrophile, and that electrophile we are converting into the nucleophile, OH. Because OH is it contains negative charge. Directly we cannot introduce the OH. First you introduce the sulfuric acid, then we'll prepare its salt, then we'll hydrolyze it. Then the sulfuric acid group will be replaced by the hydroxy group. That is, we will get the phenols. Any phenol. Yes. So now here, and another next problem is whenever two groups are lying there, with respect to which group the introduced group in the electrophile will be introduced, the group which is more electron donating, and the electron attracting group we can write in this way. And this is electron donating group. So now with respect to this is ortho-para directing, this is meta directing. If you follow this one, meta directing, then again these meta positions are vacant. If you use this one with respect to this one, ortho and para position is already occupied. So only ortho position is vacant. So with respect to both these groups, these positions will be more activated, and we can introduce the group at this position. So now first sulfonation will take place at this position, then that sulfonic acid will be converted to this potassium salt. When it is hydrolyzed, then it will be converted to hydroxy group. So now we'll get this one. This is now meta hydroxy or 3-hydroxy. Meta position or 3. We can also call it the 4-methyl 3-hydroxy 4-methyl here benzene 1-carboxylic acid. And commonly it is known as beta-hydroxytolic acid. when you get this meta-hydroxytolic acid, now if you treat with this sodium ethanol, if you remember, sodium ethanol was used for what purpose? Reduction. In the first semester we have done this one. Sodium and ethanol, it is used for the reduction purpose. So now reduction purpose, what will be reduced? Here carboxylic acid will be ring will be reduced. It is a mild reducing agent. If you take another strong reducing agent, then also the carboxylic acid will be reduced. First aldehyde, then into alcohol. So now here mild reducing agent, that is sodium and ethanol. Here we will have only ring is reduced, remaining compound will remain as it is. Now this will be the same compound. Here meta-hydroxy paratolic acid. Here meta-hydroxy paratolic acid, but here what is the hydroxylation takes place. So we can call it meta-hydroxy perhydroparatolic acid. We can say it is meta-hydroxy perhydrotolic acid, or we can also say perhydro, or 3 double bonds are there, so hexahydrotolic paratolic acid. So these are possible names. Either we say meta-hydroxy perhydrotolic acid, or meta-hydroxy hexahydroparatolic acid. Also we can give the name to this compound as it. Yes, 1, 2, 3, 4. That is 4-methyl, 3-hydroxy, 4-methyl, cyclohexane, 1 carboxylic acid. Or cyclohexane, 3-hydroxy, 4-methyl, here 1 carboxylic acid. So these all names are possible names for this compound. Now when you treat this compound with the hydrogen bromide, then nucleophilic substitution reaction takes place. If you remember, if any alcohol, this is general reaction of the alcohols. When any alcohol is treated with the alkyl halide, the hydrogen bromide, then what happens? Here nucleophilic substitution takes place. OH group is replaced by the bromine or halogen. Halogens are nucleophilic in nature, halide especially. Halonium, they are electrophiles. So in HBr, H is positive, Br is negative. Proton plus bromide. Bromide is nucleophilic. So now here we will get this compound in which remains same. Only here hydroxy group is converted into bromine. If alkyl halides are treated with this, they undergo the alkaline hydrolysis, we will get here. Then the hydroxy group is replaced by the bromine. If the alkyl halide alcohols are produced, there is the vice versa. Now here bromination means hydroxy group is replaced by the bromine. Remaining remains same. There is 1, 2, 3, 4. Then we can call it as 3 bromo, 4 methyl, cyclohexane, 1 carboxylic acid. Cyclohexane, 1 carboxylic acid we can also call cyclohexanoic acid. Sometimes you can also call cyclohexanoic acid. Hexanoic acid, cyclohexanoic acid. Hexanoic acid will contain open chain compound which contains 6 carbon. Cyclohexanoic acid, it is the ring compound, same 6 carbon. So now if you say cyclohexanoic acid, 3 bromo, 4 methyl, cyclohexanoic acid, then there is no need to give the position of the carboxylic acid. If you say in which cyclohexanoic acid is the basic compound, parent compound, but if you say cyclohexane is the parent compound, then we say 3 bromo, 4 methyl, cyclohexane, 1 carboxylic acid. Again we say if you make it aromatic, then it will be the toluene metabromo paratolic acid. But now we have hydrogenated whole of the ring. Then we call it 3 bromo, 4 methyl, hexahydro paratolic acid or perhydroparatolic acid. So now when this compound is obtained, now it is treated with the pyridine. Now again I'm just repeating one thing. If alkyl halides, this is cycloalkyl halide. So any alkyl halide when alkyl halides are treated with the base, for example, like this one, alkyl halide, if you treat with the base, like sodium hydroxide, potassium hydroxide, what happens? The halogen is replaced by the OH, will get the alcohol. Similarly, if alcohol is treated with the hydrogen bromide, or we can treat this compound phosphorus pentachloride or sulfonyl chlorides, then again this will be converted into the alkyl halide. This is the opposite reaction to each other. Here alcohol is formed, here alkyl halides are formed. So now here you see one thing, alkyl halide, when a halogen is attached to the alkyl group, it may be open chain or it may be cyclic compound like this one. Actually what is happening? The reaction is taking place in which the X that is here is replaced by this one. Another you see it is substitution, but along with substitution, here the nucleophile, you see, if the base is stronger, if you see nucleophilicity and basicity, if the nucleophile is here the reaction is taking place. For example, if we have this type of compound, CH3, CH2, here sodium hydroxide, inorganic base, sodium hydroxide or potassium hydroxide, then what happens here, potassium salt or sodium salt will be obtained. So instead of, if you use the pyridine, which is also base, now this base only will remove the hydrogen bromide molecule from here. If you write here, hydrogen from here and bromine from here, so now we'll get the compound dehydrobromination take place, and we'll get this compound. Now this is, you say again, there is 1, 2, 3, 4. If you start from here, then it is 4-methyl, 3-cyclohexene, 1-carboxylic acid, one possible name. Another will be, in the say here we say hexahydro or perhydro, but here you see two other bonds, they are possible. Now we can also say it is tetrahydroparatolic acid. It was hexahydroparatolic acid, now it is hexahydroparatolic acid. Or we can also call it as 4-methyl, here cyclohexene, 3-cyclohexene, 1-carboxylic acid. And when this compound is treated with the ethyl alcohol in presence of hydrochloric acid dilute, we can write some just make the oblate, means they are added simultaneously. We are mixture ethanol plus hydrochloric acid, and this is the general reaction. Whenever the alcohol plus in presence of acid react with the acid, what happens? Esters are produced. So if you use your methyl alcohol plus hydrochloric acid, methyl ester is produced. If you use ethyl alcohol plus hydrochloric acid, ethyl ester is produced. If you use propyl alcohol plus hydrochloric acid, propyl ester is obtained. So now we have used here ethyl alcohol plus hydrochloric acid. So now here at this position we'll get the carboxylic acid will be esterified. Here we can write in this way, ethyl ester. Now ethyl ester of this is it. One again, what you call this compound as it? Again you see 1, 2, 3, 4. Some people they also start from here 1, 2, 3 because they prefer the double bond. But now here carboxylic acid group is there. That is why I am starting from here to make it easy. So now there is the ethyl ester of 3-cyclohexene, 4-methyl 3-cyclohexene. Here 1-carboxylic acid, or ethyl 4-methyl tetrahydroparatolic acid, paratolate, or ethyl ester of 4-methyl here tetrahydroparatolic acid. If you say ethyl ester, then we say of paratolic acid. If only ethyl, then paratolate. Just a para-benzoate with the ethyl benzoate or ethyl ester of benzoic acid, one and same thing. So now here we have just converted this acid into the ester. Now it is treated with the methyl magnesium bromide. Methyl magnesium bromide, you know what methyl magnesium bromide or iodide. It is one something. So now what happens? Here it is Grignard reaction. Grignard reagent. Methyl group is electronegative. Magnesium is electropositive. Here in this case, the carbonyl group is electropositive. Oxygen is electronegative. So here polarization will take place. And now this methyl group will attack on this carbonyl carbon and polarization will take place. Now we will have this compound. Okay. Remaining compound remain as is. Here negative charge, ethyl, C2H5. Here methyl group will introduce. Once this compound is obtained, now then what happens? Again, for detail, again you can look into the reaction of Grignard reagent. There are reactions of Grignard reagent, nucleophilic substitution reactions, in which what is happening, how the reaction, nucleophilic substitution, nucleophilic addition reaction. If the Grignard reagent react with the ester, then what happens? So now here 1 mole or 1 molecule of methyl magnesium iodide is reacting with this ester. Then this reaction, and again the negative charge means 2 electron pair. Again this electron pair will come back and this ethoxy group will be given out. So now what happens? We will have the compound here. Double bond here, C double bond O, and then methyl group will remain as it is, and the ethoxy group will be given out. So here we will get the methyl magnesium iodide means ethoxy magnesium iodide will be produced. Ethoxy magnesium iodide plus we will get this compound. Again now this ketone. Which ketone? There are again different ways. If you start from here 1, 2, 3, 4, 5, then we say it is acetophenone. Which acetophenone? 4-methyl tetrahydro acetophenone, or we can also call it, you say here cyclohexene, 3-cyclohexene. So now we say 1-acetyl 4-methyl 4-cyclohexene, 1-acetyl 4-methyl 3-cyclohexene. This is now acetyl group. In other way, we can also say this is ketone. Which ketone? We say here methyl ketone, from this side methyl, and from this side this group. Now this group is known as 4-methyl 3-cyclohexenyl, methyl ketone. Yes, from this methyl and from this side.
Process. उन्हें जब पान सल्फोनेशन कराए वठनासी तो पान पाके साल्ट मिली वेंदो, सोडियम साल्ट ऑफ बेंजीन सल्फोनिक एसिड मिले त पोटेशियम साल्ट ऑफ बेंजीन।
बाबा यार हिते गाल बद ही पानी करे वठू हु त करे दिसो तो सही उनके ता हुई समझ में जो पुछण जरूरत कोन पनी ही पूरो करे वठू पान टाइम पे
उनके डाउ क्लासेस से ये बुधा तो आगे
देखो हां सर एक सल्फोनेशन फिनोल पर दूसरे हां सल्फोनेशन सही
सल्फोनेशन कराए वठने सल्फोनेशन का पो जेको पान कंटिन्यू कंदासी ना इन सा पांजो बेस सा नायो डाउ प्रोसेस
सही ठीक है सही
डाउ प्रोसेस जे थ्रू सर पान पायरोलाइसिस कराइना आयो सोडियम साल्ट ऑफ बेंजीन सल्फोनिक एसिड जी या तो पोटेशियम साल्ट सर यो बताया सर
सही
करतो सर
सही तो मन गाल समझ में अचे बे ना दुख तो कोने ना
हां सर ये बुधाएम पे ता के सर
ना वो ठीक है मैं मुझे हिते मुके करने की जरूरत कोने ने जे
ना मैं सर बीएस बाल में डिठम सर
हां तो बीएस बाल में सिंपल हालांकि बेन बुक्स में है पर बीएस बाल में सिंपल पे सफा उन जगह बुच बीएस बाल और जो
जी
पर समझ में अची और मुके हिते करने की जरूरत कोन बनी ना
जी सर
ठीक शुक्र अल्लाह। हाँ, now we have got this ketone. And if you remember the reaction of Grignard reagent with the aldehydes and ketone, there is a nucleophilic addition. If the aldehyde, this is general reaction of Grignard reagent. If anybody asks from you, what happens when the aldehydes react with the Grignard reagent? We say always secondary alcohol is produced, but only the formaldehyde. If the formaldehyde reacts with the Grignard reagent, we will get the primary alcohol. This is the reaction. Now again, remember it. Whenever in the final viva, if you are asked what happens when any aldehyde reacts with the Grignard reagent, which is secondary alcohol is produced. If the formaldehyde, only accept the formaldehyde. If formaldehyde reacts, the primary alcohol is produced. If other than the formaldehyde, any other aldehyde, if it reacts with the Grignard reagent, any Grignard reagent, alkyl magnesium halide, methyl magnesium bromide, ethyl magnesium bromide, propyl magnesium iodide, the butyl magnesium chloride, whatever the Grignard reagent, if it reacts with any aldehyde other than the formaldehyde, always the secondary alcohol is produced. If the aldehyde is formaldehyde, then always the primary alcohol is formed. If formaldehyde reacts with the methyl magnesium bromide, ethyl magnesium bromide, benzyl magnesium bromide, isopropyl magnesium bromide, tertiary butyl magnesium bromide, always the alcohol obtained is always primary. So now here it is ketone. If ketone reacts with the Grignard reagent, always tertiary alcohol is produced. Any ketone react with any Grignard reagent, always will get the tertiary alcohol. So now one molecule here of methyl iodide react with the ester to produce the ketone. Then another molecule of methyl iodide. So actually in book you will find the only two molecules of magnesium iodide will be given. So reaction is taking place in this way. In the first instance, when the first molecule of the methyl magnesium iodide react, we are getting this ketone. Then what happens? Methyl magnesium portion is electropositive. This alkyl portion is electronegative. So here polarization will take place, and we know carbonyl carbon is always electropositive. Oxygen is also electronegative, always electronegative. Just select this one. So now here methyl group will attack on this carbon, carbonyl carbon. Here polarization will take place, and now because there is no any other electron attacking group, so now here through this will pick up this methyl magnesium group. So now we will have here this compound is produced. Here C O with O, here magnesium iodide is, and methyl group remain as it is, which is already lined. Another methyl is introduced. So we'll have this compound. Here electronegative, this electropositive. And when this undergo the hydrolysis, which hydrolysis? Acidic hydrolysis. The hydrolysis will take place at this point. H positive on this side, OH on this side. So again I am reminding it, this is ketone. When ketone react with any Grignard reagent, tertiary alcohol is produced. Now here, which compound is produced? Yes, look here. Here C, CH3, CH3, and here OH. Plus will get the here now hydroxy magnesium iodide. Hydroxy magnesium iodide will be produced. So now our compound will be this compound. This compound is now here. This is known as, you see here. If I write this compound in this way, the way of presentation is different. Here I write here this carbon, 2 methyl group, and this OH. This is a tertiary compound. This is alpha terpineol. And actually by this method, whatever this terpineol is produced, this is always in a racemic mixture. Now this alcohol can be resolved by using any acid, or if it is base, then we'll use the acid. So by esterification we can get the two esters. One will be the dextrorotary, that is plus form, another will be minus. In this way, by fractional crystallization or fractional distillation, we can separate this compound, alpha terpineol. So this is the one method by which we can prepare the alpha terpineol. And this is always, you see, whatever the alpha terpineol is produced here, alpha terpineol is always racemic mixture. Now, in the starting I told you there is another simplest method that use the Diels-Alder reaction or Diels-Alder reaction. There is just only using Diels-Alder reaction is simplest reaction of all organic compound. If you look into the mechanism as well as the way of the reaction, the simplest reaction is Diels-Alder reaction or Diels-Alder reaction. Is what happens, if you remember, the activated alkenes are reacting with the conjugated diene. This is simple reaction. Conjugated diene when they react with the activated alkene to produce the cyclohexene. And we simply will say conjugated diene react with the activated alkene is known as, here it is known as dienophile. So dienophile react with the conjugated dienes to produce the adduct. Product, whatever the product is obtained, that is adduct. And that product will always contain the 6-membered ring. So now here, let me write here, and this simple, this makes sense. It was given by Elder and Vogt. Elder and Vogt. This was given in 1949. This is the simplest method. And this way, no, we have done the Diels-Alder or Diels-Alder reaction. So now let me write here. This compound here we call 1, 2, 3, 4. That is 2-methyl 1,3-butadiene, and commonly it is known as isoprene. Isoprene can 5 units. It is isoprene. The way of writing is different types. Just I have written in this way to make reaction more easy. And another compound is we use here. That is now here vinyl methyl ketone or methyl vinyl ketone. That is from one side it is vinyl group, another methyl group. It is known as methyl vinyl ketone, also known as vinyl group is also known as ethynyl methyl ketone or methyl vinyl ketone. Ethynyl group is also known as vinyl group. So we say it is activated alkene. What are the activated alkene? Alkene which contain the electron attracting group. So now if you see, look over here, this is the acetyl group. Acetyl group contain the ketonic group. Ketonic group, aldehyde group, ester group, carboxylic acid group, sulfuric acid group, nitro group, cyano group. These all groups are known as electron attracting group. So one of these groups which fits the type to the alkene, that alkene will be known as the activated alkene. So now this is the activated alkene, or we can also dienophile. And this is the butadiene. Which butadiene? 2-methyl 1,3-butadiene. And commonly it is known as isoprene. So when isoprene react with this one methyl vinyl ketone or methyl ethynyl ketone, then the reaction will take place in this way. Very simple. It is taking place in just like pericyclic reaction. So here it is one-step reaction. Now, when butadiene react with the dienophile, will be the adduct. Adduct is formed. Now, adduct, which adduct will be formed? You see, look here. Here, that double bond is formed over here. Here, it will become a single bond. Here, bond. Here, remain as it is. Ketonic group, methyl group. Again, the bond formation. When the bond formation takes place between this one and this double bond, you see, is consumed to form the bond between this one and this double bond is formed here, is consumed to form the single bond between these two carbons. So we'll get this compound. And now this compound is known as, you see, here, cyclohexene. If you say it is cyclohexene basic compound, then we start from here. 1, 2, 3, 4. 1 acetyl, 4-methyl, 3 cyclohexene. Or it is also known as, if you say it's toluene, which toluene? Then tetrahydrotoluene. There is a 1 acetyl, 4-methyl. Now, it is cyclohexene. If I say cyclohexene, then 1 acetyl, 4-methyl cyclohexene. But if you say no, it was actually it is toluene, but it is now hydrogenated, then we say tetrahydrotoluene. Tetrahydrotoluene, which 1-acetyl 4-methyl tetrahydrotoluene. Or we can also say here, if you say if it is the benzene ring, then this will be acetyl group. In acetyl there will be acetophenone. When you say acetophenone, then we call it 4-methyl tetrahydroacetophenone. But if you say it's the ketone, last time we have given them to one group, this methyl group, another group is whole group. So ketone, which ketone? Methyl, comma, here 4-methyl 3-cyclohexenyl ketone. It is ketone. Now when this ketone is treated with the methyl magnesium bromide or methyl magnesium iodide, last time we have done this reaction, methyl magnesium bromide. Then what happens here? Methyl group is electronegative, magnesium is electropositive. So here again polarization will take place. This is electronegative, this is electropositive. Methyl group will attack on this carbonyl carbon, and here polarization take place. With this polarization, this will attack on the magnesium methyl magnesium portion. So now we will have the compound. This again reacts with Grignard reaction. So here magnesium bromide, this methyl group is attached. This methyl, one methyl group is already there. So now when it undergo hydrolysis, acidic hydrolysis, now yes, it is ketone. So ketone is always converted into tertiary alcohol in this way. Hydrolysis will react. Now we'll get here CH3OH plus hydroxy magnesium bromide. So now this compound again is a terpineol, alpha terpineol. We can write in any way. Normally we write in this way. This and one and same thing. So now we will get in this way. We can prepare. This is the simplest method of preparation of the alpha terpineol. Now our next topic will be the. Now here we have done the monocyclic, acyclic monoterpenoid. We have taken at least one example from the acyclic monoterpenoid. Then this is the monocyclic monoterpenoid. Now next time we'll do the bicyclic monoterpenoid. And in this case, I think the camphor is more important. So we'll do next time about the camphor. ठीक है बाबा?
सर यहाँ जो सेट से जो हमें अल्फा टर्पिनॉल मिलेगा उसका भी रेसिमिक मिक्सचर मिलेगा?
नहीं, इसमें डायरेक्ट हो, इसमें रेसिमिक नहीं मिलेगा. इसमें डायरेक्ट बनेगा जाकर अल्फा टर्पिनॉल.
सर नेचुरली केडी
हाँ, अच्छा. रेसिमिक मिक्सचर मिल दो है. रेसिमिक मिक्सचर में आयल में जो बुझो रेसिमिक मिक्सचर 30 डिग्री में जगह होंगे. रेसिमिक मिक्सचर मेल्टिंग पॉइंट है वो रेसिमिक मिक्सचर में मिल दो है.
जी ठीक सर.
ठीक है. बंद क्या?
जी सर.